Well, welcome to the April 5th, 2022 session of Tangerine SDR and Hamside technical session. My name is Dave, KV0S, and this week I've been cleaning up the house, dealing with a few contract projects, and I have been doing a little bit of ham radio stuff, but nothing, no big projects quite yet. So that's about it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. It's been a busy week here. I actually had Bob Inderbitson and another Alex Nordstrom from the ARRL come visit Scranton last Thursday and Friday. And they did a recording of me where I'm working on a project with them and with Tamitha Scove for a video. So they did that. But then we also had a kit building night at our school club. And so the students, we had 16 students build little AM FM radio receiver kits, and then Bob and Alex were able to watch that as well, so that worked out really nicely. And then I hired a new Masters of Science and Software Engineering student to work on the Trip Sounder project, and she'll be with us for the next year until she graduates. So she's kind of doing a soft start today, and she'll be working with Simmel. And then all of the other students are working on projects and things are moving along. And Dev is continuing to work on his paper for the Trip Sounder too. So hopefully we will bring that to publication. W2NF, back to Nat.
Well, fine business. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Not too much to report on the Tangerine project. I've been working on the NASA stuff quite a bit and trying to get spiff up the illustrations and get a manuscript ready, and also got an ICOM ID 5100A and installed it in my car because we're getting ready to take a trip out to California for a couple of weeks, and I wanted to have a radio in the car. So, but that's neither here nor there. Anyway, back to Nat.
Well, sounds like a fun project. Next on the list is Bill in 8ET. Go ahead, Bill.
On the right mute button. I finally got something to report this week. Last week, Friday, about Thursday, Friday, I guess, talked to my wife and told her I just needed to spend $100 on a GPS local oscillator, and then I could get going on the space weather project. Said, well, why don't you just order the damn thing and get it over with? So I jumped on the internet and ordered my Leo Bodnar GPS discipline local oscillator. And this morning it showed up on my front doorstep Friday to Monday from England. So FedEx is working real well. And so I've got the local oscillator, I've got the Raspberry Pi, I've got to get downstairs and fire up the receiver that I built 6 months ago and haven't turned on yet, and see if it works. And hopefully by next week, I'll be able to say I'm receiving data and can be transmitting that into wherever it goes to. So we're on the way. Back to you.
Well, fine business. And next on the list is Dan, N4XWE. Go ahead, Dan.
Okay, thanks, Dave, and good evening, everyone. I worked a little bit more on the script for compiling the Tangerine SDR software. I have not really run into any problems, but it's a really long, involved compile. So it's taking me a little bit more time than I thought it would. I think maybe by Wednesday or Thursday, I'll be able to run the full script and see how it goes. So it usually works out that you write the script, you run it a few times, and the first few times you run it, you have a problem here or there. You fix the problems, then everything works wonderfully well. So we'll see how it goes. Back to you, Dave.
Well, good luck with that. Next on the list is David McGaw. N1 HAC. Go ahead.
Good evening, everyone. I was just watching the premiere of Ben Franklin and had to break in the middle of their treatment of his studies in electricity.
Yes.
So I'll have to go back. I know they'll be replaying it ad nauseum, but fascinating stuff. And when working on radios and solar systems this week, solar power systems, and found an interesting problem testing our radios at the lab. Found some really heavy pulse noise actually saturating the preamp, and turns out it's the blower motor, well, the fan motor for our fume hoods, which apparently has a variable frequency drive on it that is putting tremendous noise out. And I don't know if I'm going to be able to get powers that be to filter it, but we'll do what we can. But it's, radiating far more than FCC, I think, would condone. So that was an interesting development for this week. And I guess there's too much more. I guess I'll leave it there. Back to net.
Okay. Next on the list is Gary, AF8A. Go ahead, Gary.
Hey, good evening, everyone. I'm happy to report, at least for myself, that I was able to get my feed line buried for my HF antenna last week. We had a one-day break in the weather on Thursday, so I missed all the teleconferences on Thursday. But I got an antenna feed line. It's underground. Got a big pile of rocks too that was a side benefit. And now we've got to wait for another break in the weather to get some radios buried. And then that's one more project out of the way. So that's it for now. Back to net.
Well, fine business. You're making headway. Next on the list is Hillman, KD2 MCR. Go ahead, Hillman.
Yep, good evening, everyone. Not so much to report other than I reinstalled our magnetometer at Jenny Jump, and then the data are now being fed to the data archive that Dave Witten has established. So we are back online and working on a lot of magnetometer data stuff to understand interhemispheric responses to MI coupling system. But other than that, yep, that's nothing to report. So back to net.
Well, fine business. And next on the list is James, KG4 DSG. Go ahead, James.
Evening, Dave and group. Not much to report here. Just turn it back to the net.
Well, fine business. And next on the list is Joe, W7LUX. Go ahead, Joe.
I can get myself unmuted here. Good evening, everybody. Installed the two programs to upload the data from the grape to a repository, and I'm not having much luck here. The one program took like 20 hours to maybe more than 20 hours to upload 11 months of data. Lots and lots and lots of failures. So I've got to go back and waiting for a list of the ones that made it or the ones that didn't make it so I can fill in the holes there. And it's been rather trying. Anyway, that's pretty much what's happening from Northern Arizona. Thank you, Dave.
Well, very good. Well, next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. Nothing much to report this week. I'm still building up my list of parts that I need for my Ebnot rig, adding them to the DigiKey cart. With things like this, you always think of things that you need after you've placed the order and paid for shipping. But that is moving along so slowly but surely. There has been a fairly exciting week in solar activity last week. March 30th, there was a really nice SID that I observed on NAA and a bunch of other transmitters. The enhancement, the signal enhancement amplitude is about as high as the it's about as high as the normal diurnal when the transmitter is switched on. So that was a really nice enhancement. There was some really good solar activity. I didn't capture anything else, and I didn't capture any cores or anything like that. That's all I have. Back to the net.
Okay, next on the list, we have Michael Howen, AC0G. Go ahead, Mike.
Good evening, everybody. I got back from Puerto Rico last night, so I haven't been doing much actually in the shack this week. Haven't been doing anything in the shack this week. We were on a service trip with my younger son, 17 years old, helping rebuild some things at a school up in the highlands in west central Puerto Rico, a town called Ayuntas. Anyway, and we made it back through Miami of all things last night, which was probably lucky under the circumstances. Before I left, I did get a RSP Duo set up on the standard grape RPI setup, and it's governed by a Leo Bodnar GPSDO. And so fortunately for me, it seems like the transmission script is working and the data is being uploaded. I hope that's the case. It looks like it's working successfully at this end anyway. And I'm hoping that it's useful data. I think would like to get a better understanding of how to make sure that's the case. It looks stable, and hopefully it'll fit in with what everybody else is observing. Otherwise, it's nothing else from me. Back to net.
Very good. Next on the list is Michael AA8K. Go ahead, Michael.
Oh, thank you, Dave. I've been trying to copy the HARP transmission from the Alaska Poker Flats. And of course, they've been scrubbed all each time. And I'm trying to catch up on my sleep. Back to you, Dave.
Well, hopefully you can. Next on the list is Scotty, WA2 DFI. Go ahead, Scotty.
Okay, hold on. There we go. Okay,
Yeah.
that's better. Let's see what's been going on this week. I finished up the loopback board for the data engine for the clock module, which is basically a little dummy clock module that plugs onto the data engine that allows signals to be looped back so we can test everything do a self-test on the data engine. And almost done with the other two boards, the leaf and the RF module. Just have to make a couple changes. There's a few signals that don't go to the FPGA. They go in between boards. So you have to kind of be tricky there and feed them over to signals that go to the FPGA so you can stimulate every node on the board. And I did get some interesting news last week. I'm not sure, maybe I told you this last week, but our schedule for FPGAs for the data engine is in May. So it's actually appears on the ship list. So from Intel. So
This is the ARIA 10s?
No, this is the Max 10s.
Really?
Oh,
yes.
Did you get that email on
wait. Yeah, I'm going to fall out of my chair.
Yeah, don't fall out of your chair. But don't fall out of your chair until they actually show up here.
Okay.
Did you get the email on April 1st?
Yeah.
I I don't believe you, Scotty.
Yeah, well, that's not unusual.
Scotty, is that 2022 or 2023?
2022, that's what they said.
No.
Like I said, I'm not believing them until I see the parts show up. But keep in mind, we ordered them in March of last year. So it's been
Oh
over
my
a year.
gosh.
So it will be over a year by the time we get them. So I don't know. I will. But that's the thing is, once they appear on the schedule, supposedly, I mean, with the Aria 10s, when they appeared on the schedule, we got them on the day they said. So, but they weren't on hard allocation like these are. So we'll see what happens. Anyway, that's the exciting news from here. If that actually happens, and we'll have data engines easily by the summertime. So, because it's all ready to go, just waiting for that one part.
And that's great, because then we could get the 1 year no cost extension on the grant, and we might actually be able to do this.
Might actually get this to work. And the RF modules and clock modules were supposed to be done, but Tom, I checked into those. This is a sad story. Okay, we had the regulators that we got were the 150 mil ones that we decided were probably pretty marginal in not being able to work. Well, turns out, I mean, how stupid can you get? I went to On Semi. I found new regulators from On that were the same exact pin out and 500 mil regulators, and the ones we had spec'd that I had spec'd were automotive AEC, whatever the number is, automotive grade. And those were the ones that were out of stock on Obtainium. Well, they've got a commercial grade part that changes 2 letters, and it's the same exact part, only it's not automotive qualified. And Mauser has 20,000 of them in stock.
So you'll have a couple leftovers?
Yeah. So needless to say, being obnoxious as I am, I ordered 100 of them because I'm not going to have this problem again. And but it turns out that the CM had already installed them on the board. So now we're going to go back and have them removed, the 150s removed and the 500s put on, so we won't have any problems. But just, if I'd known a day earlier, they wouldn't have had them mounted, and I could have just slipped them right in and we would have got our boards. But and then on the clock modules, the battery backups that he had, I don't guess he didn't read the data sheet, but he ran the batteries through the reflow oven. Well, let's just say that they melted. Okay.
That's not recommended, right?
No, I'm surprised he didn't get a fire.
Yeah.
Because they're lithium primary batteries, and they're little bitty things. They're about the size of your pinky nail, and they're SMT, got SMT leads, and there's no plastic on them anywhere but the seal between the plus and minus leads. And if you melted that, I mean, could have got a fire in your reflow oven. It would have been a little hotter in there than you had programmed. But anyway, so we had to order some more of those. So I don't have either the clock modules or the RF modules yet, but by next Monday, I will have both of them. And they're in my bag going to Hambention for those of you who are going there. And we have the schedule all is set and in for Hambention. So we have Jonathan, you're on the schedule. Bob McGuire is on the schedule, and John Ackerman is going to talk about the clock module carrier board. So we got our 3 presentations. And I hope, Nathaniel, you got your booth space squared away. Have you done?
Yes. So the booth, I will be next to you.
Okay.
Yasmi is going to pay.
Oh, cool.
Yes, because it's a long story, but they will happily. Everyone is very happy. I have to turn in my talk list, but I should be able to do that tomorrow. Because I think you're going to give a talk in my session. Veronica will, Diego will, and Bill will. That Bill right there.
Okay. So we have 15-minute talks, or that's about right? Shorter?
Probably a little longer, because I have an hour and 15 minutes. So 4 talks in an hour and 15 minutes.
Okay.
Yeah.
Okay, so 20 then.
Yeah.
Or a little longer. Yeah, or 20 plus questions.
Yeah, something, or it's like, yeah, well, something like that.
Okay. And your forum is Friday afternoon or Saturday?
I thought it was Saturday.
Saturday,
I have
okay.
to double check. I owe a lot of emails. So I don't know
And
how
if-
much energy I'm gonna have tonight.
I think if you have SDR specific additional talks, I think Steve's still looking for maybe one or two in the SDR forum.
Okay,
More inclined toward SDR rather than space weather station. So
yeah. I don't think I have one ready to go. So,
yeah, I'm not. I mean, I can always talk on something, but he hasn't
Yeah.
asked me directly. And
Right.
I'm going to wait and see if he fills the spots because I'd rather have him do that than. But if he
Yeah.
gets desperate, then we're always the last ones he calls on, right?
so I guess what I have to do too is I need to set up, I guess a booth schedule, and I need to have people order ham sci lab coats again. So I need to get that information out really soon.
Oh,
so
okay.
People can get their lab coats and things.
And you have a banner or something you can. A banner to
A
put up
banner?
behind?
Yes.
behind the- okay.
Yeah. So I can bring, let's see. So you saw the banner we had at the ham sci workshop.
Yeah.
Yeah. So I have that big banner and I have two smaller banners.
And that one has rings in it, right? So we can hang it from the back?
Yep.
Okay, perfect.
Yeah.
And then we're going to have a digital voice demo. And if I can con Dan into bringing his couch antenna, then we'll have a SDR demo as well as the actual Tangerine boards. So Dan, can you bring your demo?
Sure, no problem.
Okay. And then we'll have lots of good stuff to demo at not quite enough to sell yet because I pretty much decided I'm not going to try and kill myself and get the magnetometers out and try to get ones to physically sell. We will take orders for them, take an interest list, if you will, a sign up sheet for people who are interested. And then when they become available in the next week or two, we'll email them and say, here they are, go order them. And that's actually one of the other things I want to do is I want to write up a detailed user manual for the released one, for the production model, with a picture of the model and where all the jumpers are and what they all do and all that. So make it easy for people to modify it and do things that they want. That's it. Back to you,
That's
Dave.
it. Okay. Next on the list, we have Todd, AD0RR. Do you have any comments, Todd?
Yeah, so timing is everything. I just got notification from SparkFun that they are shipping my I2C extender so that I could kind of hack together a magnetometer waiting for the commercial one to become available. And I ordered it back in September and they just gave me a ship notice saying, hey, it's in its way. And so now you're ready to sell it. So I'm going to have a couple extra parts, but that's okay. Extra parts are always good. So other than that, I'm dug a hole last fall because I was afraid of the winter. And so now that it's springtime, I'm going to be able to put it out there. So I'm running DRF. So I've been looking forward to this, but that's it. Back to net.
Okay. And last on the list is Tom N5EG. Go ahead, Tom.
Oh, good evening, Dave, everybody in the group. Let's see, I reviewed the schematic of the data engine adapter board, which hopefully maybe we won't even need. I don't know. If your news is good, we might not even need that, but I printed it on A-size schematic and I put it under a ring lighted magnifying glass and then needed a second magnifying glass under that. And even then it was hard to read the the light gray print, but I think I had to get my wife to help me on a couple of the letters, but we got it done and reviewed and sent an email out. So the schematics look fine and everything looks really good. And that's it for the week.
Okay. Well, I believe that brings us to the end of the list. So we should be open for general discussion.
Yeah, Tom, if you print it on B size, it's readable with only reading glasses.
Yeah, all they need to do is get a B-size printer, but I'm sure they're out of stock.
I'll send you mine. There's no drivers for Windows 10.
Oh, no.
So I have a Windows XP machine here that has the printer on it. That's its sole use, is to print
Yeah.
things.
You can probably print it split between 2 pages too.
Yeah, you might be able to do that. and
Do
tape them together.
do B-size that way.
That's all right. I have a D size plotter, I want to say. It's a D size plotter that my CAD guy gave me about 10 years ago, and I never messed around with it. Well, I gave it to another guy. Well, he found Windows 10 drivers for it. So I should be able to print actually one bigger than my rule of thumb is you should never draw anything bigger than one size larger than what you can print. So since I have a B size printer, I do C size. Well, if a D size printer, now I can do E size. It's still printed, but the paper is like, this one, you got to buy it in a roll, and then you have to use little ink cartridges, which I'm sure are god awful expensive when you draw an entire diagram like that.
I had one of those when I was at work for printing maps.
Yeah. And like it's not 22, it's 36 wide, right? I think
Yep.
it's 36.
No, ours was 48.
48.
48. So that would be an E size printer then, I think. Yeah.
And as long as the roll didn't run out, you could print as long as you wanted.
Well, how about the pens? The pens are only like the size of one joint of your pinky, so they must run out pretty quick.
Oh, they do okay.
Oh, okay.
You'd be surprised.
Yeah, Scotty, I got a question about the Max 10s.
Sure.
Could you refresh me and maybe the rest of the group? What was the quantity ordered originally?
25.
25. Okay.
Right. And we
So
couldn't
I
get
guess-
any, so.
But now that we're going to get 20, now that we're going to get them potentially, that means we should build 25, right?
Oh, yes, definitely.
Yeah.
And I'm going to go ahead and build the adapters anyway, because
Right.
then that just gives us more boards to check out. I mean, something to use our boards that we paid money for.
Yeah.
And so we'll see how that goes. I don't really think I need to build 25 adapter boards because we only have 11, I think, 11 or 12
of the
PK bits,
development
PK
kits.
boards. Yeah. So really don't need that, at least right now.
This is the best.
Yeah,
news
you
I've heard
counted
all
them
day.
last week. I think you said 11.
Yeah, 11. So, in fact, I don't have it written down here, but I think it was 11 or 12. So
This is very, very exciting news, Scotty. I'm very.
If we get them, it's like I don't like being excited and then disappointed. It's
True.
like.
Well,
so
I
we'll see.
mean, if we
Yeah,
don't
11
get-
is the number that we came up with last week.
Okay.
If we don't get them, we still have Plan B, which I had kind of resigned myself to. So
Yeah.
Yeah,
Because once I get those parts, it's only a matter of maybe 3 weeks before I can get the boards built because all the parts are here.
Can your board shop X-ray the BGA packages to make sure they're all connected?
Yes.
Okay.
Typically, what I'm going to do is I'm going to have these loopback boards that one of our grants paid for, and I'm going to plug them on, and it'll test every single FPGA connection to the board. So if I have any opens or shorts, it'll be able to detect those, and then we can X-ray them to try to get them repaired. So the trouble is that X-ray is a little difficult because the way you get an open is the ball of solder balls up and doesn't flow onto the pad, and that's really hard to see from the top. You got to really go in at an angle, and so it becomes difficult to actually see. Although what you might be able to see, shorts of course are easy. What you might be able to see is a general non-wetting of the pads if you kind of angle the thing, and then you know you're in trouble. So
Scotty, do we need to test the FPGAs themselves or X-ray them to make sure that they're the real thing before you solder onto boards?
Normally I don't if I get
like getting counterfeit ones or something.
Normally I would not do that because first of all, it's very hard to test unmounted BGAs.
Yeah.
And second of all, we're getting these from Arrow through Intel. So this is not like a gray market or anything. Now, a customer that I work for is so desperate to get FPGAs, they're paying for Max 10s. It's in a different package than us, but for Max 10s, they're buying them from China for 20x the going rate. And the gray market guys who are selling them to them want to grind off the date codes because they don't want them going back to Intel and saying, are these legitimate, trying to supply chain and trace them back and or blockchain them back. And so that says to me, first of all, Intel doesn't know that they're selling them, most likely, or gouging the prices. And second of all, I wouldn't, that's like buying a car with the serial numbers ground off. It's like, you don't know what you're getting. Those I would x-ray to make sure there's a chip inside. Yeah, that's dangerous.
Yeah, there's a 7400 quad NAND gate inside there.
That's right. Or they just connected all the wires, bonded them all together to one plate.
Hey, we have continuity.
That's right. It's good. So yeah, so this could be really exciting news. I mean that's only like I think it was May 20th, so it's like 6 weeks away.
Just for Hamvention.
Just in time to miss Hamvention.
Yeah.
So I'll get the email while I'm at Hamvention that they've been delivered.
Yeah. That's okay. Then we'll have a big celebration at the Tapper Ham site booth.
That's right.
You should live stream it. Do you have one of those like Amazon rings?
No, but I do have what's an Amazon ring?
It's those doorbells that Amazon sells that have a little video camera built in. We can live stream the delivery of the FPGAs to your front porch.
I see it at the house, right? There it is. There comes the box up onto the porch.
Yeah, you can do a play-by-play. It'll be.
Yeah, be careful because you might also see the porch pirate taking off with it. So
that's right. There'll be a vehicle behind the truck that says Gray Market Electronics Inc.
Yeah. Well, if we broadcast it, there will be. No, I get noted to take the box inside, open it up, and take a picture of the vacuum sealed envelope with the parts in it. We don't open the envelopes.
Do they ship those in some kind of a plastic carrier to keep the balls intact on the bottom of the ball grid array?
They do. They ship them in a tray.
Okay.
Cut out for each one, and then they put the tray in a vacuum sealed bag along with a bunch of desiccant and a moisture detector even on the outside.
Okay.
Because apparently, if they ingest too much moisture, they can crack the ceramic or some other damage the package. If you heat it,
It also doesn't solder properly.
Yeah, you get corrosion and moisture in the flux and all kinds of stuff.
So we don't open those until they're ready to be soldered down. I let the CM do that.
Okay, good.
But so the shock would be if you opened the package up and there was like rocks inside or something. Your parts. But I think we have a few words to have with the distributor. After all, we're not buying them from China with the numbers ground off. We're buying legitimate ones, supposedly. So that's kind of why I want to get going on these loopback boards, because I'm going to need these to test the data engine.
Mm-hmm.
So to make sure all the connections are good, even the connections that we don't use have got to be tested, because someday we will use them, and then you want to make sure they're good.
Yep.
It's the same kind of thing we did with HPSDR. I had loopback plugs, and since they were DIN connectors and they were like 10th-inch centers, I made them by hand. But this is way too hard to make a 140-pin loopback. There's no way I could do that by hand. So we're going to have it on a board that would plug on, and it loops back the signals to itself and to other boards. So, and these are easy because they're all DC connections. The test runs at a really low speed, so they don't have to be matched pairs, or they don't have to be impedance control or nothing. So the guy our CAD guy can just whip these out in no time at all. And he's actually right now he's working on the DE adapter, and we've got that all read in. He's got the placement, And I showed the placement last week, didn't I?
Yeah.
I mean, I showed the one with the real size of things, not the one that was just a board with everything all stuck on it.
I think you showed a board with all the parts off on the left side or something.
Oh, okay. Well, let me find the one that he sent me that has the real placement on it.
Yeah, that was like the rat's nest, do all the
Yeah.
parts fit placement.
This will still be a rat's nest, but it shows where we mounted the boards because we had to move things around to make it actually work. So carry on a second while I try to find this. And because I'm pretty sure he sent me I'm sure he did because I had to approve it. So okay, I found it. It didn't take very long. Assembly drawing. That's not very good. Oh, come on. Someday I'll learn how to use a computer. Okay, this will be good.
You realize computers are like cats. They use you.
Yeah. That explains why I have so much trouble. Okay, this is the picture that we want here. I can somehow get it over onto this screen. Okay, well, you're going to get a lower res version of this then because I can't get it onto the big high res screen. Okay. So this is the layout of all 4 boards. Is that coming through okay?
Mm-hmm.
So over here on the left in the blue is the Max 10 development kit with its HSMC connector right here. And this is the dual stack Ethernet connectors down in the lower right of the DK board. Then the data engine is, I guess it's like a salmon colored, and it comes out and it's notched right here. Okay, so it comes straight across the bottom, up about halfway, jumps out, goes up the rest of the way, and then straight across, and then straight back down. So that's the size of the adapter. And then the RF module is shown plugged underneath it with its SMA connectors facing upwards. Okay, but it's below the adapter. And then the clock module is on the lower right, and it's above the adapter. It's on the top side. And the TI evaluation board for the VLF receiver is in the upper right here. This is the large guy here. And this is why we had to notch this out here, because this is the connector for that board. So we needed to get it on there without overlapping the SMAs over here. And then we bring the SMAs for the clock module straight out. And its connectors right here, and the standoff is right here. So it'll be mounted to the board in 2 places like that. This will be mounted to the board in 2 places here. There are no holes here in the TI board. These are for standoffs that will go from the data engine down to the ground, if you will, that will be tall enough to get it off the desk enough to put the RF module below it, and then the evaluate the DK board, which is at the same vertical level as the RF board, right? Because they both plug on the back. Although I got to say the RF board is closer to the module, to the adapter, than the DK board is, because there's between the DK board and the adapter, there's 5 millimeters of height. That's what this connector is, this HSMC. Between the DE board and the RF module is, I believe, 2.1 millimeters of height. So it nestles right down there. And then between the adapter board and the TI board is 5 millimeters also. And between the adapter board and the clock module is 4.1 millimeters. And so here we have jumpers for options that the FPGA can read on the DK board. So we got 10 jumpers. And then I took it upon myself to put an OLED display on the top of the adapter board just to add some flashiness, because I was figuring that I was going to have this by Hamvision, and it would be cool to put up a Tangerine logo or something up on the display just to show that it's alive and working. And in addition to that, there's an LED for each power rail, and then there's the pass-fail LED down next to the RF module connector, same as there would be on the data engine. And no other LEDs than that. We're going to use the display for whatever we want to do.
Scotty,
Yeah.
What is this? Hang on, let me draw here. What is this thing? Well, I need a different color. What is this thing right here?
In the middle there, the big square rectangular thing?
Yeah.
That's the OLED display.
Okay, got it.
That faces upward. Yeah, you put a circle or a line around it. And this is kind of an X-ray view, so you're seeing what's on the RF board and what's on the data engine together. The stuff that's not this salmon color, that's on the top of the adapter board. So the display here, this down here,
be the A to D converter.
That is no, because there's no A to D converter on here because it's on the RF module. Well, yeah, that's true. It's salmon, so it's on the RF module. And our power supplies for the data engine adapter are right in here, because I told them I wanted to keep the LDOs. I don't care where they go because they don't create any noise, but the switcher is right in here, and I tried to keep it down on the over the RF module where the digital part is of the RF module. I'll keep it away from all the analog stuff up here.
Okay, yeah, so they're right over on top of the 20 dB amplifier,
right
driver. So they're right on top of the analog circuit.
But there's 4 ground plane layers in between.
Yeah, and those analog parts are facing away on the opposite side of the board pair.
Right. So you got 2 board thicknesses plus 2 millimeters plus 4 ground planes that it all has to go through. So unless there's magnetic coupling, we should be okay.
Yeah.
So ground planes should take care of that too.
If we want to probe the RF board circuits with an oscilloscope, how do we do that?
All of the components on the RF module are on the top, which faces away from us. So you turn the whole assembly over and you got access to all of the parts on the RF module.
Okay, so you have to mount everything else facing down.
It's
and the RF module facing up.
No, it's mounted the same way as it will be on the data engine. It's back to back. The data engine and the RF module go back to back. And we kept all the parts on the RF module off of the back except for bypass caps.
Right. Yeah, so we have to pick up the assembly of 4 or 5 stacked modules here and then turn that over so that we expose the RF module.
Right. And that's why I was really concerned that all of these bolt together.
Okay.
There's no Mr. Floppy. I mean, it's going to be rigid. I mean, it's going to be somewhat fragile because it's pretty low. And to give you an idea, the distance here is about 5 inches, 125 millimeters across the top.
Mm-hmm.
So it's really not that big. I mean, the whole thing is only going to be about like this. So you just have to be careful when you turn it over, I think, and have no problem. You just won't be able to see the display, the fancy display with it turned over, but you'll still be able to get at everything. And on the TI module, the inputs, Jonathan, your inputs here for the 480C channels are over here on the right to their Phoenix terminal block. So they'll come off to the right, those 4 inputs. And and the clock module is actually right in here is where the USB port is to program the clock module and configure it. And there's actually a MMCX connector there that you can use to take one of the clock module outputs off board and use it for whatever you want, just to play around with the clock chip, program it, and try different things. And then you could take that same programming and move it to a different channel of the clock module, and then that'll drive the RF module or the FPGA. And I think
Is
I'd
there
have
an option to get one PPS out of that clock module?
yes, the one PPS is connected up. It's on that connector. It's just a second. I will bring that up and show you what is on there.
Just for the sake of prototyping, because what I wanted to do, mainly as a test signal, this isn't going to be normal operation, but what I wanted to do is I wanted to be able to feed the one PPS into one of the audio inputs of the ADD converter, just as a test.
Okay, let's see. Yeah, actually, you know what? The one PPS doesn't go into that Nectar connector. I could feed it into one of the GPIOs.
No, well,
I mean, well, what did you want to do with it again?
I wanted to feed it into one of the audio inputs of the ADD converter.
Oh, okay. So you're going to feed it into one of these four guys along here, right?
Yeah.
Well, the one PPS comes out on one of these SMAs, so you can just jump right over.
Oh, okay. All right. Well, then never mind. Yeah, perfect.
Yeah, these three SMAs are for the GPS antenna, for the 10 megahertz reference in, and the one PPS out.
Oh, okay. Okay.
And actually, that output is programmable as either 10 megahertz or one PPS, whichever you want. So
okay. And that one PPS output comes from the GPS module, right?
that comes from the GPS module, yes.
Yeah. Okay.
And we're building all 25 of these with the high performance F9T module.
Oh, good. Good.
The dual channel one that we can do TEC measurements with.
Yeah. Good.
So, yeah, so let me show you here the clock module. Okay, let's do this. Let's try it again here. Okay. So I don't know if everybody can see this. I can make it a little bit bigger. But the GPS RF is to the 10 megahertz. And the GPS PPS is, of course, PPS. And the high performance module is this one here, the ZF9T, the upper one. This one will not be installed. So you get actually two outputs. And they're programmable. So you can make one 10 megahertz and one PPS is the theory. And then if you go to the, let's see, hold on a second. Yeah, so the PPS comes out on this guy here, but you can make that 10 megahertz if you want, but it's normally set up for one PPS. And then on the actual IO connector, which would be this guy, which is on the data engine, we send 10 megahertz and PPS both. That's a little hard to see here. Let me make it bigger. But we have the GPS PPS here and the GPS RF. This goes out on the M.2 connector, but that's not really accessible to you. That goes to the FPGA. So you'll get it off of this connector over, I mean, the SMA connector.
Okay, perfect.
Well, that will work?
Yeah, that'll work great.
Okay. And these boards I should be getting any day now. Not that I can do a lot with them yet, but we'll, and I think the clock modules are going to be the ones that are going to be in the most demand because they'll work on this adapter board set and they'll also work on the real thing. So we get the data engines, we're going to have to share clock modules between the adapters and And not only that, we're coming out with the next, and I think the last board that I have on my plate in the series, other than the Mark II engine, which is later on now, will be the clock module carrier, which is going to be the next one that I'm going to do. I've got most of the thing blocked out. John Ackerman and I have been sending emails back and forth, talking about what features we want to have and how we're going to bring it out, bring the points out. And I think I showed that to you guys last week, the tentative layout of the board. So that'll be falling in right behind these, because that'll be really useful to test the clock modules with, that board, that carrier. Assuming I can get all the parts. I haven't started assembling parts for that. Although I did get the microprocessor that we're going to use as an ARM. It's the same one that Adafruit uses on their what's it called? Dan, you remember I told you it's like a basic stamp board, but it's not a stamp. They got a clever name for it. It's an $8 microprocessor board that's about like this big. And so we took the same processor and we bought the raw parts. So we're going to put these on the clock module carrier to be the one to manage the non-volatility of the configuration of the clock of the GPSs and the synthesizer. So when you power up, it can go out and load a known configuration, and then you can plug a USB computer port in, talk to it with a serial port, change the configuration so the next time it powers up with the one that you specify. So, but since we use that same part, we can use all of Adafruit's, their same operating system, software, whatever, however they run that board, we can borrow it all because we're going to use the same part with the same pinout. And all it is really a USB to I2C converter. A little bit more than that because it's going to do the initialization too. So we'll have some custom code in there to do that. And I think John will hopefully be helping us decide what to set the part to out of the gate. And then of course the FPGA, once you plug it on a data engine, the FPGA will be able to do the initialization for us, like in this case, where we have an adapter board or a data engine, because that I2C port connects to the FPGA, so we can set it up any way we want.
Yeah, Scotty, I wrote a Python script for the Python GUI that can talk to all of the module registers on the receiver, on the clock module. It knows how to read the clock programming file and send it to the clock module.
Oh, great. So we can just dump that right into the clock module. That's for the GPS or for the synthesizer?
For the synthesizer chip, not for the GPS chip.
Okay.
So the synthesizer, you can output a text file that contains all the programming for the synthesizer, and the GUI I've got for all the register manipulation knows how to read and load and send that to the synth chip.
Perfect. So you'll be ready when we send you these parts.
Well, yeah, we have a little bit of Verilog we're going to have to do first.
Yeah, a little bit.
No. It's not much for the clock. We do need a 4-wire to 3-wire SPI converter for the receiver, which should be a tiny amount.
So that's a tiny amount, yeah.
And then that'll, once we get that, we can then start programming things.
Yeah. Are you coming to Hamvention?
No, I'm not going to be there.
Okay.
Scotty, should I mail you my evaluation board?
That wouldn't hurt if you don't mind. And then when I send you a board back, I can send your board back with it.
Okay.
Can we buy more of those boards if we need to?
Yeah, but they're $200.
Is that just for the evaluation, or is that for the pair?
That's for the pair. I don't think you could. Well, I don't think you could buy just that evaluation board or the duck board separately. I think you have to buy a pair.
Oh,
that's
okay.
$200 from TI.
That's too bad, because the EVB ought to be much cheaper. Do you know the part off the top of your head for the evaluation board?
I'll put a link to it in the chat.
Okay. Yeah, because it would certainly be nice if we could buy that board by itself. Because most of the logic is on the other board, so this would be a much cheaper board. It basically has a bunch of connectors and one chip on it.
I don't think you can. I think you can only purchase it as a pair. You could have the board. Well, I mean the Gerbers are available, so you could have the board made. And I believe the Gerbers include stencils for placement. You could go that far if you want, but I don't believe that it's available separately. It's supposed to be sold as one unit ready for evaluation, not necessarily for our use.
Yeah, because that's really beyond the scope of where I want to go to do that.
Yeah.
I got enough boards to build as it is.
Yeah.
But I can't buy parts for. Let's just see if anybody. Nope, that's not it.
Yeah, one of the bummers is that this thing costs so much. But I think the reason for all that cost is their valuation platform. And there's like there's a USB interface and some code and another codec and all this stuff. It's a fairly oh, here it is. Yeah, it's a fairly ready to go product, but unfortunately for our purposes, we can't really use it. Here, I'm posting the link.
I found it on DigiKey, and they sell it as a pair. So
yeah, is it over $200? Because on TI's website it is $199.
it's $238 on DigiKey.
Yeah,
I'd noticed that if you get it straight from TI, it's less.
Yeah, DigiKey
But
has
it's still
17.
$200.
So yeah, but you know the FPGA boards were $200 too. So if we needed to buy one or two of these, I think we could do that if it helps anything.
yeah. Well, I mean, I would like to kind of share this one that we have as much as we could. This way, not to add any extra expense, because it's only going to be one or two people doing the development of the code of the Verilog, probably me. So, but let me know when you would like it sent, and I will ship it to you.
Okay, I'll drop you an email.
Okay.
And yeah, thanks, Dan. That board, the Adafruit board, is a trinket. And last I looked, they didn't have any in stock. Let's see. There it is, $8.95.
Yeah, I believe they're out of stock.
Yeah, you know why? Because I bought up all the processors. Well, 30 of them anyway. No, I was looking at this processor here that they have on the board. and thinking we should use the same one. I went on and I did a search, and I found that I think Mauser, either DigiKey or Mauser, was the only one that had any in stock, and they had like 29 of them. So then they were like $2.50 a piece. So I just bought them, all of them, figuring that that's the one we're going to use. So you might as well buy it now while you can still get it, because the lead time was like, 2 years. But it uses a
It's an Atmel chip, isn't it?
yeah,
Like a tiny 85 or something like that.
It's an AT SAM D21E. Oh, let me put it in the chat. Wow, that's like the world's smallest font. Can everybody see that? That's the processor. And let's see if anybody has them. My money is on nobody has them. Out of stock, out of stock, out of stock, out of stock. Nada. And I mean, this is great. Mauser has 29,000 of them on order. Online Components has 2,000 on order. Oh, everybody has them on order, but nobody has any parts. Oh, wait, I take that back. Oh no, those are different Adafruit boards that they have in stock, but none with the part on it. The chips are like not here.
What's the trinket being used for?
Good question. I'm not sure. Here, I'll show you again. This is the trinket M0. I guess it's just it's an Arduino board, but isn't it Arduino? It's a processor board, isn't it? So I don't quite understand what this is used for, but other than to play around with Python.
Yeah, the Arduino is not a full-blown computer. It's more like a programmable logic controller.
Okay.
Yeah, it's a microcontroller board.
Yeah.
That's an Atmel processor.
Right. Which is now microchip.
Yeah.
Can't keep these companies straight without a program.
So it's an upgrade of an AT Tiny 85. It looks like, for a Cortex M0. So that's the part number. 256K of flash, 32K of RAM. So anyway, we use this for a housekeeping processor on the carrier board.
Oh, they've updated that to a Cortex M0?
Yeah.
Oh.
See right here?
Yeah.
Whoops. So it's a 32-bit processor, runs at 48 megahertz.
It's $9.
And that's the board is $9. The processor that we bought is like $2.50 or something like that. And basically we're using it to get the USB port and the control internally, an I2C internally, and then we hook that to the clock module. And that's and so now you've got a USB converter with a processor in line and an I2C out the other side. Now you can do protocol translation. You can store your initialization table in the ROM on this board, and when it powers up, you can have it load the synthesizer, or like Tom says, you can load the. I don't know how. Is Tom still here? I can't see if he's still here.
Yep, still here.
So do you think that this processor will be something that we could parse that ASCII file into I2C commands?
Oh, yeah, probably. What I'm doing on my code is I'm parsing it into the TangerineSDR UDP packets that go out on the Ethernet, the module read and module write commands. And so it's sending them out in that form. And then when the FPGA Neos processor gets it, it pipes those over the I2C. That module there, if it has I2C on it, then you should be able to parse it pretty much the same way in Python, except instead of emitting module read and write commands, you just emit I2C.
Okay. Yeah, because on the standalone board, of course, we won't have the FPGA, so we have to have something to do that initial.
Yeah. Right. Or you could probably just hard code it into the flash on that board.
Yeah, yeah.
Yeah,
Or we could plug the computer onto the USB port on the carrier board, because that goes right into the GPS. So that to program the GPSs, that's fine, except the synthesizer has only an I2C port. So you have to connect to it some other way.
Right, right. So it's fairly straightforward to program it. It's got a couple of banks of 256 registers, and you basically read and write a byte address and then a byte data. And then there's a bank select command that you have to use for some of the upper registers.
Okay, and then you could program all 10 outputs to be all dividers and.
Yeah, you can program everything on it. You need to use the Clock Builder Pro. You know, you go in and configure everything you want, and then it emits an ASCII file of all the register addresses and all the contents to program. And that's easily parsable in Python.
Okay. Very good. Amazing for $9 though, that you can buy something like that.
Yeah, I mean, a Cortex M0 is a pretty decent processor.
Yeah. And I don't, let me see if this is wishful thinking.
I think Adafruit wrote, they wrote their own version of Python that I think it all runs and compiles in the Arduino IDE, and then it will compile the Python rather than the C-like code that a normal Arduino uses.
Okay. I believe this highlighted one is the one that we bought here for $2 a piece. We bought the last 25 of them, 29 of them. So yeah, so that was the whole idea, is to use some other environment that we can get hold of and not have to invent our own. I guess we're going to use one like that, the QFN. So that's what's up next. Actually, try to make some progress here. So Nathaniel, we need to start thinking about where these are going to go. You're muted.
Sounds good. We will do that.
Nice problem to have, huh? Finally.
Finally. Well, I'm sure Bill AB4EJ is going to get a couple of them.
I'm sure. And we talked a little bit about how to do an initial load of basically, instead of implementing the whole protocol, just to do a hardwired port and IP number and just spew the data out that way, format it and send it out UDP, and that way you get real data real fast. And I presume for Tom, that's what you would want too, is just get raw data to start with.
Yeah, it depends on where it's going. On the receiver debug, the first thing is we've got to get all the registers being able to be read and written, because there's a ton of configuration registers on that ADC. And so step one is being able to read and write back the registers in the ASICs. And once we can do that, then we can start testing.
And we have to also, like you said, initialize the synthesizer and make sure it gets its clocks.
Yeah. So that's fairly easy to do. You have to have Clock Builder Pro, which is the GUI version. You go type in all the synthesizer, what frequencies you want out and what outputs they go on and what their levels are and what the input reference is. You fill all that out in a GUI, and if you have the eval board hooked up, you can program it directly. And if not, you can write an ASCII file, which has got the contents. And then that ASCII file, you could store somewhere on the processor to basically initialize it on power up.
And then hopefully we can just distribute that ASCII file to all the developers and they just load the same one.
Yeah, exactly. And so there's a bunch of options. I tried to put it in the module read and module write format because my intention was I wanted folks to be able to write something like a bash script or some kind of config script and basically boot up TangerineSDR with receiver and clock settings and everything off a single script file. And that way, if they have different experiments, they could just have different script files to boot up the whole system to whatever they want for their experiment.
So you could boot up with different clock speeds or...
Yeah, different clock speeds, different receiver configurations, things like that. And having that in a text file, I think will be useful for a lot of people.
So why are there so many registers in the ADC? What?
It has 259 byte registers in it. There's a lot of empty ones, and I think 26 of them are used, but they scan from address 0 up to address 103 or something like that. So they scan a couple of pages of registers.
So if you're doing sequential writes, then you have to write all the dummy ones too, even though they don't do anything.
No. The first byte you write is a page selector. The second byte is an address within the page. And the third byte is the data value at that register. And you can skip around in random. It's basically like random access. You can program them in any order you want.
But do they have an auto increment or do you have to do the address for each register?
I think you have to do the address for each register because you don't use sequential registers in a lot of cases.
Okay.
It's not that hard to do.
Just seems like there's a lot of them.
Yeah, there are, but like for our application, 26 of them are used, I think.
And then there's also the attenuators you have to select and the noise generator and all that. That's all I2C.
Yeah, that's the other, that's on a different, that's on I2C control interface. The ADC is programmed on the SPI interface. And then the ident EEPROM is on the ident I2C interface.
So there's really two I2Cs and an SPI then.
Right. The I2C control is easy. It's just 1 byte. And there's the 8 bits correspond to the 6 relays and the 2 LEDs. And then I forget which one turns the noise source on and off. Oh, the noise source is connected by 2 of the relays. So the noise source is always running if you strap it on, but the relays route it they either route the antenna to the receiver or the noise source to the receiver. And when the antenna is routed, the relay actually terminates the noise source in a 50 ohm resistor. So it doesn't interfere with the receiver.
So it's a quiet noise source, so to speak.
Yeah, it's fairly quiet. It's a 10 dB excess noise. So it's not that strong signal to begin with. You have to, it's pretty far down into the noise figure of the receiver.
If I remember right, we have a strap we can disconnect the power from it if it's making trouble.
Exactly.
Yeah, so.
Yeah, so that it's fed by a 10 milliamp current source, which takes nominally 12 volts in, but it can be down as low as 10 or up as high as 14 or something. And it'll source 10 mils into the noise diode. So it's pretty loose on what it takes on 12 volt supply.
Okay, yeah, I was specing the 12 volt supply at 11 to 15, if that works.
That should be fine.
Yeah. All right. So the first thing to do would be to toggle the LEDs.
Yeah.
The Hello World program.
Yeah, toggle the relays, toggle the LEDs. Once that works, then we need, and then read the ident EEPROM. And if all that works, then we know the wiring and the modules and the devices are correct. Then we need to implement the Verilog for the 4-wire to 3-wire SPI conversion. And then we can test reading and writing all the ADC registers. Once we can do all that, we've come a long way to debugging the board.
Yeah, we have to make sure to strap the VDDIO for 2.5, and at the same time, program the FPGA data pins to be LVDS. And I think it's not a problem because the only pins on the board that are outputs are on the I2C or the SPI port.
Okay.
And the sync port, which you got a level translator on. So all the rest are inputs. I'm just worried about apply because the absolute maximum rating of the ADC is 1.8. So if we apply 2.5 to any of those inputs, bad news.
They're toast.
You got to make sure that that's set up before we do anything else.
Yeah, all the SPI things, I Schottky diode clamped
Yep.
to the 1.8 volt rail.
So
And
it should be more than 2 volts anyway.
Yeah, they'll have a hard time trying to go over 2.0 volts.
Yeah, so, okay. All right. Sounds good.
Alrighty.
Scotty?
Yeah, go ahead, Jim.
I just doing a quick review of the data sheet for that 895 processor. The USB support on that seems to be very low level. And you're going to need something a little higher than that to talk to like a serial port, if that's what you're talking about.
Well, I think that the GUI that Tom mentioned talks through a USB port. So it should format through that port.
Well, USB talking to what?
Yeah, Scotty, the what I wrote talks on the Ethernet interface.
Oh, right. I keep forgetting the USB, the GPS has a USB port that we bring out, but the synthesizer does not. Okay, so yeah. So the processor, you said, doesn't have a real USB port?
Well, it's got a real USB port, but it's at the packet level. The classes that define the device are the next level up, and that's a software thing. It may be something that's available from I guess it's microchip, I guess, at this point.
Well, but I'm thinking that our USB interface is going to look identical to the Adafruit board. So whatever software they have to talk to that via USB, that's what we're going to use. So hopefully they got drivers and higher level things that we can talk to.
Okay, they may have gotten them from whoever's made.
Hopefully they've got some way to talk to it in Python, and then we'll be writing Python scripts.
Well, it's probably serial. I mean, that's pretty standard.
You may want to get online and look for what do they call it? They have a name for it, Circuit Python or Micro Python or something.
Yeah.
You might want to get online and see what library support they have.
Let's see if it says on here. It says native USB supported by every OS, can be used in Arduino or Circuit Python as a USB serial console, keyboard, mouse, HID, even a little disk driver storing Python scripts. But I'm presuming that that's not, I mean, you got to write code to do that, right?
Right, but they may be including it.
Okay.
The processor itself just deals with packets.
Okay. So it's not like a USB to serial port stuck on there.
No.
Okay.
There's a layer above raw USB that's called the class driver level, and that's what defines what those packets mean. And there are serial class drivers, there's keyboard class drivers, there's network class drivers, just basically a class driver for every device that works on USB. But those are a level above the hardware USB, which the processor does.
Okay. Well, what I'm thinking is that we can put a FTDI chip on here and hook it to two of the other pins on this processor. And there's a UART inside that you can connect to those pins. And then we can talk just serial bytes. Just UART, just, it'll look like a serial port.
Right, right. They've implemented it in hardware, the FTDI stuff. But I don't get me wrong, the processor can do it. The question is, where can you get the software?
Okay, I'm just looking for something really easy. And if it makes putting a $2 FTDI chip on there, I'll do it. Because being a hardware guy, you know, I'd like to be able to plug it into my computer and have it go, oh, look, a serial port. What do you want to send to it? Right, look, let's fire up putty and talk to it.
I'll look into this. That $8.95, and actually DigiKey's selling them for the same price. You can order them from DigiKey.
Do they have any?
Oh yeah, like 500 of them.
Really?
I think that's what it said.
Okay. It's a Arduino or a Adafruit number 3500.
Yeah, I did have it up, but I guess I closed it. And the data sheet's on the microchip site, so I may be looking into that for other reasons. It's an interesting processor at that price.
Let's see, they have 570 in stock.
Yeah. The one other weird thing is they quote it as a USB 2 port, but it's limited to 12 megabits.
Oh, okay.
So it's not a, well, if you're just doing serial, it doesn't matter.
It doesn't matter, right? Because we don't need the performance.
But it's kind of funny that it's USB 2, but limited to 12 megabits.
But yeah,
which is really USB 1.
That's just full speed, right?
That's full speed. Yeah.
Yeah.
It's not high speed, USB 2. Which I find strange, but usable.
Yeah. Well, probably for this level of processor, that's not.
Well, the processor's running at what, 48 megahertz?
Right.
It's not going to do 480.
Right.
Yeah, well, 480 is actually USB 3. And there's 5 additional connections in the connector. It's a 9-pin connector.
Yeah.
But you can't see the 5, they're hidden back inside. Well, productive week. I've got to run. See everyone next week.
Yep. 73, Tom.
I think I'm gonna go 2, Scotty.
Yeah, me too.
7-3.
See everyone next week.
Good night, 73.
Hey, Dan, you're going to be around for a little bit. I'll give you a call.
Okay, I'll do that.